Density equals mass divided by volume. We can flip this relationship around. We can say that volume is equal to mass over density. So that's the other side of the triangle, mass divided by density. Okay, and then we can also say, well, if we are looking for mass, density and volume are beside of each other, so mass is density times volume. Okay, when they're beside each other, you multiply. When they're on top of each other, you divide. So density is mass divided by volume. Volume is mass divided by density. Mass is density times volume. So let's use these relationships here and solve some problems. So the first example here says a cylindrical piece of wood has a diameter of 2 feet and a height of 5 feet. The cylinder has a mass of 600 pounds. What is the density of the wood to the nearest pound per cubic foot? So we're wanting density. Density equals mass divided by volume. I encourage you to set up the ratio every time based on what you're looking for and what you're given. What you're looking for, you need by itself. So we're looking for density. Density is mass divided by volume. We were given mass. It's 600 pounds. So we can go ahead and plug that in. Divided by volume. Were we given the volume? No, we were not given the volume. But we were given dimensions, and we were told that this is a cylindrical piece of wood. So let's figure out volume. Volume for a cylinder is pi r squared h. Okay, volume for a cylinder is pi r squared h. So let's plug in the specifics. What is the radius? 1. The diameter was 2, so the radius is 1, and the height is 5. Let's leave this in terms of pi for the time being. So 1 squared is 1, 1 times 5 is 5, so our volume is 5 pi cubic feet. Okay, so now we have volume, so we divide mass by volume. Now, obviously, when you put this into your calculator, you don't divide the dimensions. Okay, we're just writing it there for later. Be careful with this, though. When you divide by 5 pi, you must put parentheses around the 5 pi. Okay, you must put parentheses around the 5 pi to get it correct. So our density here is approximately 38.197 pounds per cubic feet. Okay, density is always going to have a weight unit on top and a volume unit on the bottom because you have divided mass by volume. So that is our density. Okay, let's look at a different scenario here. A certain type of metal has a density of 5 grams per cubic centimeter. A piece of this metal has a mass of 2 kilograms. What is the volume to the nearest cubic centimeter? So we want to know volume. Volume, let's go up to the triangle. Volume is equal to mass divided by density. So mass over density. So let's see here. What do they give us? They give us density, 5 grams per cubic centimeter. They also give us mass, 2 kilograms. This doesn't come up a whole lot, but you must always make sure that your units agree. These units do not agree. We have grams in our density. We have kilograms in our mass. So how many grams are in a kilogram? How many grams in a kilo? 1,000. So the mass, yes, is 2 kilograms, but so that our units agree, we need to express that as 2,000 grams before we plug it into our formula. So volume is 2,000 grams. Density is 5 grams per cubic centimeter. 2,000 divided by 5 is 400. The grams cancel. Cubic centimeters are our units for our volume. So that answer is very different. Then I just divided 2 by 5. 2 over 5 cubic centimeters versus 400 cubic centimeters. You've got to make sure that your units agree. Like I said, it doesn't come up too often, but you do have to kind of keep an eye out for that. All right, density doesn't always have to do with mass and volume. Density, we can talk about population density as well. So in general, density is your amount over your space, but it's the same thing. Amount, how much you have. Well, if we apply that specifically to weight, how much we have, we could weigh something to tell how much we have. Over space, how much space does it take up? Well, that's the definition of volume. Volume is how much space is taken up by this object. We're just applying it in a more general term here. So we can be talking about people, we could be talking about animals, we could be talking about anything when we're talking about this kind of density. So let's look at this example. Beijing has 20.7 million people and an area of 16,400 square kilometers. Shanghai has 23.7 million people and an area of 6,300 square kilometers. How many times as great is the population density of Shanghai as Beijing? So let's find the densities first of all. I'm going to use a B for the density of Beijing. So it's amount 20.7 million. Now, for the sake of trying to calculate this, I'm going to express that in millions. So 20,700,000 people over 16,400 square kilometers. So 20,700,000 divided by 16,400. There are approximately 1,262.195 people per square kilometer in Beijing. That's a lot of people. Because a square kilometer, I mean, it's a pretty good size, but you're talking about fitting almost 1,300 people in that space. Okay, let's do Shanghai. Shanghai is 23,700,000 people in 6,300 square kilometers. Now, I think it's pretty obvious just based on the numbers that you can tell Shanghai is more dense before we even truly calculate the density, because it's definitely more people in a smaller space. Bless you. I think that was a sneeze. 3,761.905 people per square kilometer. So about how many times as big is that? Well, how about we divide? So about 3 times larger, or 3 times as dense. So for every unit of measurement in terms of space, Shanghai has about 3 times as many people as Beijing did. That's a lot.